Hi friends! You're watching Funimation 3D. Have you ever had this happen? You're warm and comfy in town. Then you travel up a mountain and suddenly you're like, whoa, why is my nose cold? Oh, today we're solving that mountain mystery. And I promise, by the end, you'll be able to explain it in one simple sentence. Here's the big idea. The higher you go, the air gets thinner, and thinner air can't hold warmth as well. Picture Earth wearing a huge invisible blanket made of air. That blanket is the atmosphere. Gravity pulls air downward, so the air is packed the most near the ground. That's why we say the air is thicker down low and thinner up high. Now imagine two places. First, a super crowded school hallway between classes. Second, a giant gym with only a few kids inside. In the crowded hallway, you're always bumping shoulders. In the empty gym, you're spaced out. Air molecules are kind of like that. Near sea level, there are lots of air molecules packed together. Pressure means how hard the air is pressure means how hard the air is pressing. Down low, there's a lot of air above you, so it presses more. Up high, there's less air above you, so it presses less. Pause and think. If you had a big stack of pillows on your bed, where would the pillows be squished the most? At the top or at the bottom? Chanel. Give it a second. At the bottom. The weight above does the squishing. Air works the same way. More air above equals more pressure. Less air above equals less pressure. So up on mountains we get lower air pressure and thinner air. Now here comes the coolest part. Literally, when a bubble of air moves upward, it reaches places with lower pressure. That means the air bubble can expand, like a sponge relaxing when you stop squeezing it. And when air expands, it cools down. Let's make that feel easy. Imagine you're holding a springy sponge in your hand. If you squeeze it tight, it's packed and squished. If you release your hand, it spreads out. Air does something similar as it rises. It spreads out because there's less pressure squeezing it. And here's the key. Spreading out takes energy. When air uses energy to expand, it has less energy left for heat, so its temperature drops. That's why we say, rising air expands and cools. Picture this like tiny bouncing balls. Warm air molecules bounce faster. Cooler air molecules bounce slower. When the air expands, those molecules have more space and bump into each other less often, so it feels cooler. Pause and think again. If you spread a group of kids far apart on a playground, will they bump into each other more or less? Wait, less! And in air, less bumping is part of why it feels cooler up high. Now, there's a simple weather rule that matches what people notice in real life. On average, when you go up about 1 kilometer, the air can get about 6 to 7 degrees Celsius cooler. That's called the lapse rate, a fancy name for temperature usually drops as you go higher. And quick note, it's an average. Weather can change it a bit, but it's a great memory tool. Okay, so thinner air and expanding air help explain why mountains are colder. But there's another big piece, how the sun warms Earth. You might think, but mountains are closer to the sun, shouldn't they be warmer? Smart thought. Here's the twist, the difference in distance is tiny. Mountains are only a teeny bit closer to the sun, not enough to matter. The real reason is this. The sun mostly warms the ground first, and then the ground warms the air. Think of the ground like a giant warm plate. Sunlight hits roads, sand, grass, and rocks. Those surfaces soak up energy and heat up. Then they warm the air touching them. That's why the warmest air is often close to the ground, especially in sunny places. Down low, you have more air packed near that warm ground, so it's easier to build a cozy layer of warm air. Up on a mountain, the air is thinner, so there's less air blanket to hold that warmth. Plus, mountain wind often moves faster and can carry heat away quickly. Here's a fun metaphor. Warm air near the ground is like being wrapped in a snug hoodie. Thin mountain air is like wearing the same hoodie, but it's unzipped and flapping in the wind. Not as cozy. Wow! Fact number 1. That's why you can see snow on mountaintops while people down below are wearing short sleeves on the same day. Same sun, different altitude, different air. Now let's connect this to everyday life you've probably seen. Imagine you start a hike in a valley. It feels warm, and you're like, I'm fine in my t-shirt. Then you climb higher. The air pressure drops. The air gets thinner. Rising air expands and cools. Wind feels stronger. Suddenly you're like, okay, where is my jacket? That's why hikers love layers. They can add a hoodie when it gets colder and take it off when it gets warmer. Wow! Fact number 2. Weather reports often give different temperatures for the city and the mountains nearby. That's not the forecast being dramatic. That's altitude doing its thing. And here's another cool example. Airplanes. Planes fly very high where the air is extremely thin and very cold. Outside the plane can be way below freezing. That's why airplanes have special systems to keep the inside comfortable. Wow! Fact number 3. At high altitudes, water can boil at a lower temperature. That means it can boil sooner, but the boiling water is actually not as hot as boiling water at sea level. Wild, right? And yes, adult supervision only if you ever see this in real life. Now let's do 3 quick brain experiments you can imagine safely. First, imagine a balloon at sea level. The air is pressing on it more. Now imagine that balloon higher up where the pressure is lower. The balloon would want to expand more because there's less squeezing from outside air. That's like rising air expanding. Second, imagine a thick comforter on your bed versus a thin sheet. A thick comforter traps warmth better. A thin sheet lets warmth escape. Thicker air down low helps trap warmth more than thinner air up high. Third, imagine standing still in a warm room versus standing in front of a fan. The fan doesn't create cold out of nowhere. It moves air and carries your body heat away. Mountain winds can do the same, making you feel colder faster. Pause and think one last time. If you climbed up 1 kilometer, would you expect it to get warmer or cooler? Wait, cooler, often by a few degrees, around 6 to 7 degrees Celsius on average. So here's the full mountain answer, all tied together. Mountains are colder because the air is thinner and the air pressure is lower. As air rises into lower pressure, it expands and cools. And since the sun warms the ground most, the air closest to the ground tends to be warmer than the air high above it. Less air, less pressure, more expansion cooling, and often more wind. Hello, mountain chill! Now you know the secret. The next time you see a snowy peak above a warm town, you can explain it with confidence. Higher altitude means thinner air, and thinner air holds less warmth. If you enjoyed this science adventure, please like, share, and subscribe to Funimation 3D so you can join us for the next one. See you next time!